This is operational Buddhism, building reliable services from unreliable components. We're not going to meditate. This is really just a philosophy of dealing with services in the cloud. So this is going to be a presentation full of a lot of swearing, a lot of cats. So I hope you're cool with that, and if you aren't, well, too bad. Just a little bit about what we're going to cover. Who am I? How did I get here? How things were done in the olden days, and then what happened with the rise of utility computing, otherwise known as the public cloud. We'll talk about a little bit about how we do things at Pinterest, and how we practice this thing that I've kind of come to call operational Buddhism. There's four noble truths to that, kind of mirroring traditional Buddhism, a little bit what we do, and then some things that we chose not to do. So who am I? Why am I here? I've been database engineer at Pinterest since January of last year. I'm one of two people that runs our MySQL infrastructure, and that's it. There's two of us. I'm loosely affiliated with HBase Core SRE, so it means I do a few other things here and there. Before that, Percona, MySQL consulting company, maybe you've heard of, maybe you haven't. Sun, lots of little companies that I know you've never heard of. And I like to think that I'm jack of many trades, master of some, and then there's some things that I don't know anything about at all. And so why am I here? It's because I'm cursed with being interested in pretty much everything, and that's tech, science, math, politics, philosophy, art, music, whatever. And SRE is a good cross-discipline area. You really need to be good at a lot of things and understand a lot of different things and be able to put them together to really be any good at this job. A little bit of Pinterest overview. So we're 100% Amazon. It's all in the cloud. Petabytes of data, MySQL, HBase, S3. Redis, not so much as a data store, more of as a cache, but it's still there. And at any given time, there's tens of thousands of servers. How many, I don't know, but there's a lot. Hundreds of different services. Again, how many, I don't know. There's services that I don't know what they do. I just hear their names in passing. They interact with each other, they come and go. And there's certain Amazon offerings that we use a lot of. We use a lot of EC2. Hey, give us some servers. We use a lot of S3. Hey, give us some space. DNS, through Route 53, Redshift. But then there's some things that we either don't use at all or we don't use very much of. And these tend to be more of the sort of platform as a service offerings, like RDS. Give me a database, I don't care about anything else. CloudFront for CDN. Amazon has so many things that I've lost track of how many there are. And again, there's a lot we don't use. The core ones are probably those four. So now we're going to take a trip back in time. What did we do before the cloud? It hasn't always been here. So this is pre-AWS. It's pre-Google Cloud, pre-Azure, all that stuff. And what did you do if you wanted to be on the internet, if you wanted a computing presence? And there weren't that many options. Either you use a managed service provider, you rent some space and let them deal with it. You build it yourself. But in the end, this is really all kind of the same. It's servers. It's all servers all the way down. And it's your problem. Whether it's your problem directly or it's your problem indirectly, there's still all these physical boxes that you have to deal with. And whether it's you, your ISP, whatever, somebody has to get them. They have to rack them, stack them, configure them, make sure they work, plug them in, make sure the cables aren't jacked up, and things are labeled, et cetera, et cetera. All this physical stuff that you have to think about. And so that really kind of leads to what I'm calling the four sorrows of operational materialism. And these are that individual servers matter. If you have a physical box, this is a lot different than having a virtual instance. It's a physical machine. This box matters in some way. Failure is expensive. If your server goes down, your site might be down. So you're going to spend a lot of time, a lot of money, a lot of resources, energy, intellectual capacity to making sure that you can prevent failure as much as possible. And what this leads into is a situation where capacity planning can really make or break you. And sometimes, even if you have the best capacity planning models, you still can't necessarily control your destiny. And so what does all this mean? So a server dies. This is a physical box. So now what do? Maybe you have a hot standby. Maybe you don't. Maybe you have spare parts. Maybe you can just go down to this data center and swap out some RAM or put in a new hard drive. Cool. Well, you maybe don't have that either. So you get on the phone with Dell or HP or IBM or your vendor of choice and say, help. my server's down, my site's down, I'm screwed, what the fuck? And hopefully you bought their super expensive service plan that they sold you on that you didn't think you would need, that you actually need this one time, because they will actually send someone out that hopefully can fix it. If you didn't do that, and it's Sunday afternoon and your server's down and you don't have spare parts, well, you could be in deep shit. And so, failure is expensive. Your server's down, your site's down. What does that cost you? Previous job of mine, we used to call this the Lamborghini Factor, which was how many minutes of downtime before our CEO couldn't buy another Lamborghini. This was also, you laugh, but it's true. It was also how we measured the cost of projects. We want to do this. Oh, well, that's going to cost him 2 Lamborghinis. So what does this cost you for lost business? What does it cost you to take your employee time to go fix it? What about your reputation? Oh, your site's been down for the last 2 hours. Your customers are pissed off. Are they going to come back? Maybe they will, maybe they won't. Either way, these are situations that we don't want to be in. And so we spend money, we spend time, we spend resources to make sure we don't get there. We buy better hardware, we buy spare parts, we buy spare hardware, we cluster out, multiple this, redundant that. Anyone who's ever been inside a data center or worked in that level, you've seen it all. Cables here, cables there, redundant this, redundant that. And hey, guess what? You also need extra humans because, if one person gets hit by a bus, it's over. It doesn't matter how much redundant hardware you have if there's only one person that knows how to run it. But the thing is, if you want another 9 to your availability, you better be prepared to add another 0. This stuff is not cheap. You add extra servers, you buy, blades for this and dual power supplies for that. You've got more cost. You add cluster management software and network file systems, you've got more complexity. Oh, and then you get more humans. And then that's pretty much every kind of pain imaginable. More cost, more complexity, all of it. And so this is what Efficiency Cat has to say about that. Well, that just kind of sucks. What it also means is that capacity planning is important because today I have N number of servers, and I think, all right, hey, 6 months from now, I'm going to have this surge of growth. I'm going to buy some servers. I'm golden, right? Well, what if you don't buy enough? Well, then your customers all come in, they get a bad experience, they get pissed off, they leave. That's not so good. What if you buy too many? Well, then you've spent too much money, you've wasted resources that you could have spent elsewhere. And really, what this all comes down to, it's a problem of time. How long is it between the time that I say, I need a server, and I have a server, and that server is ready to go? It could be an hour, could be a day. Well, it's not going to be an hour if you have to order it from somewhere and it has to get built and shipped to you. That could be weeks, could be longer. And then once you have the servers, what are you going to, if you don't need them anymore, well, you've paid for them, you still have them, what are you going to do with them? And even when you get all of this right, or as close to right as you think you can get it, basically shit still goes wrong. Natural disasters, typhoons hit, earthquakes happen, supply chains just go AWOL. If anyone remembers 2009, trying to get a Cisco ASA was next to impossible for a few months. Legal conflicts, people get sued, companies go out of business. And I'm sure some of you remember the Slashdot effect. Oh, hey, look, that website looks fantastic. Oh, nobody can go to it because it's on the front page of Slashdot and they didn't have enough servers. That's not cool. So, I'm kind of painting a sort of bleak picture of all of this, but really it's not all doom and gloom because before the cloud, before utility computing, this is how people did things. They bought servers, they racked them, they stacked them, they configured, they did the best they could. Things worked this way for years, and it was frustrating at times, but okay, it worked. Some people still do it this way because they're still very physical server oriented. But for a lot of organizations, the landscape is completely different. For smaller organizations, things are fundamentally different than they were 10, 15 years ago. I've been doing this since 1996, and I've seen a lot of stuff. And 20 years ago, there were no clouds. It was servers, all servers. And so then things like this happen. We've got web services, Azure, Google, countless others. And what does that mean? So In theory, it means you've got all the capacity in the world at your fingertips. You just need a credit card. You just say, hey, I need some servers. I plug in my credit card, spin me up some boxes, and hey, there they are. You couldn't do that before. This is a sort of a democratization of technology because it means anybody can do it. Anybody that's got a credit card, internet connection, hey, give me some servers. So now you can focus more on building your product, your next great idea, whatever it is that you want to do, and you don't have to spend all that time dealing with servers and infrastructure and whatnot. And it makes experimenting really easy. If it doesn't work, okay, well, you turn it off. I mean, you didn't spend $50,000, $100,000, some ridiculous amount of money on stuff that, well, in the end, oh, well, that was a bad idea. Now we have a bunch of paperweights. You just say, oh, no, that's it. Footnote there, some of the promises are more easily kept than others because the cloud's not unlimited. I mean, who has ever gotten the insufficient capacity exception from Amazon would know. I can't say, I want 1,000 servers right now, please give them to me, and know that I'm going to get them. I mean, sometimes it works and sometimes it doesn't. But, as with everything, there's no such thing as a free lunch, and if you want to go that route, there are going to be trade-offs. You have reduced architectural flexibility because you get what they offer you. You have a limited number of types of servers you can choose from. Your network topologies are fairly limited. You're really just a giant black box. Here's some infrastructure. Who knows what's underneath? Is it server-grade hardware? Is it commodity-grade hardware? Who knows? It's just, here's some servers, go ahead. And one of the things that can translate into is unpredictable performance because, again, you have no visibility. You may have noisy neighbors. Things may be great most of the time. They may not be. But it's, again, you're sort of subject to the whims of what they've given you. Then you sort of have this vendor lock-in problem. So the more that you kind of get embedded with a particular cloud provider and use their offerings more and more, especially the ones that are specific to them, well, the harder it becomes to leave. I mean, if you just say, hey, I've been going with cloud provider A, and this is all great, and no, wait, now they want to double my rates, I don't like this, I want to go elsewhere. Oh, well, now how am I going to do that? Because getting my data in was easy, getting my data out, maybe not so much. And you get some interesting challenges to cost containment. I mean, yeah, it's great that anybody can spin up a box. Anybody can spin up 2 boxes. But what happens when somebody spins up 500 and forgets about them for a month? Oh, well, yeah, then the bill comes and you're like, oh, that's kind of not so good. So the old mindset, operational materialism and capacity planning based on logistics and all of that sort of physical server mentality, that's not going to work here, and we need to look at things in a different way. And so the approach, something that I'm calling operational Buddhism, and the idea is don't get attached to your servers, you won't suffer at a high level. And so there are 4 noble truths to operational Buddhism. I'm not going to bother to read them here because I'll go into them in detail on the next slides. But essentially, it's don't get attached to your stuff, things change, and if you design around an infrastructure that is inherently flawed and ephemeral, if you know that going in, you can work around it. You can build services that are just as reliable, if not more so, than what you would do on physical hardware, and life is good. We break the cycle of suffering, and we reach server nirvana, I suppose. So, number 1, failure happens. I mean, at any time, for any reason, your virtual machine can go away. I mean, as a whole, cloud providers tend to be fairly reliable. But any one particular box, who knows? You might get the email, say, oh, hey, we're going to terminate your server in a week because something's wrong. Could be underlying physical hardware's gone bad, disks, network, whatever. You've got your noisy neighbor problems. I mean, maybe there's a problem with the hypervisor. And then you all have that sort of mysterious cascading failures from elsewhere. I mean, the public cloud providers' environments, they're very large. Things could happen that have nothing to do with you, but somehow they end up having something to do with you. And so if you get attached to your servers, that leads to suffering. And if you try to prevent server failure, forget it. I mean, you cannot stop these things from dying because you have no control. You have no visibility. You cannot make any guarantees at all about something that is that ephemeral. And the other thing to note is that virtual machines really do fail at a much higher rate than server-grade bare metal. I actually, on a particular fleet of ours, about 600 boxes in it total, 3 died yesterday. Just poof. It happens. But we dealt with it, we moved on. And so the idea here is you want to be failure resilient and not failure resistant, because you cannot resist something that's going to happen anyway. And if instead of spending your energy on that, you spend your energy on dealing with systems and creating systems that can accept, oh, hey, my server's gone, or what have you. And I mean, I'm sure some of you have heard the cattle not pets phrase. So that guy on the left, well, I guess actually on the right, sort of the far right, if you don't like cats, then maybe you don't care, but I'm a cat person. That's not a server. I mean, if something happens to him, I'm gonna try to help him out. But these guys, well, I'm sorry, animal rights folks, but I don't have much love for you because I can always get another one. And then finally, the cycle of suffering, we can break this. We can build systems that work really well, and really the best infrastructure is the ones that the people above you don't see. Your developers, they don't know, they don't care, because they don't have to. Your stuff works, and everybody else is just like, oh yeah, or we don't talk about availability because we don't have to, because it's great. Our numbers are fantastic, and I mean, it kind of sucks because nobody knows all the hard work that went into doing what you're doing, but at the same time, it's like, cool, things work. Nobody's yelling at us. Shit's not on fire. And so, how do we do this at Pinterest? This is going to be very high level. If you want more details, I'm the guy with purple hair. You can find me later. So the main thing is automated replacement. Obviously, auto-scaling groups are good for this. And they can really be good even if you only have one back-end node. I mean, if you only need one back-end node, if you auto-scale, you say, I always want one. If the thing dies, comes back up, goes behind an ELB, done. The deployment auto-scaling platform that we developed in-house called Teletran, named after the computer in the old Transformers animated show. That's open source, the link's down there at the bottom. That handles deployment, auto-scaling. There's another automated remediation framework called Morpheus, not open sourced yet. Maybe later this year, I don't know. I wrote it, it actually just went into production this week. And really the idea here is destroy all the humans. Automate as much as you can. You don't want have to page people in the middle of the night for things that code can do for you. And obviously, configuration management software is really important for this. We use Puppet, you use Chef, Ansible, Salt, whatever. Religious wars are for religious people. I mean, use whatever works for you. They all will get the job done. Just pick one, be consistent with it. Don't turn it into a bloody mess, and you'll be good. And so, again, don't even try to prevent server failure. If server's having a problem, shoot it, terminate it. Don't waste your time trying to fix it because, I mean, yeah, maybe you could, but it's probably a lot faster. Just say, oh, goodbye, I need another one. Provision yourself, join the cluster, do whatever you need to do. You might want to keep the thing around because you want to do some forensic analysis and satisfy your own curiosity, and hey, that's fine. But as far as keeping your operational uptime going, forget it. I mean, it's not always necessary to know why. I mean, that's actually hard for me to admit, but sometimes it's just like, you know what, I don't care. I have other things to deal with. And so, some design patterns that can sort of work in this environment. Obviously, retry logic, back off. That's sort of obvious, but some people don't. The second one here, hard-coded host names. For the love of all that is good and holy, don't use hard-coded host names, please. Because when things die, new things get replaced, they're probably not going to have the same host name. And if you've hard-coded DB server 001A-1, well, your shit's broken. And so we have a suite of tools that actually are open source, footnotes there. Overall, it's something called Kingpin, and it's based on Zookeeper. And the idea is you're using Zookeeper for service discovery. Services don't need to say host, DB001-1A. They just say, I want the master for cluster 1A. We'll give it to them through Zookeeper, say, okay, this is the current master, connect to that, cool. We do a failover, master changes, pick up the new configuration from Zookeeper, go on about your life. Great. And we can converge 20,000 hosts in under 10 seconds. So when things go wrong, and we have to do a failover, or we push out new boxes, the updates get out there quickly, things just sort of pick up the new information, and they go on with their lives. And so, yeah, what if I told you there is no cat? You start to get into this mindset, and you have this solid infrastructure, automate yourself out of the shit work, but then you also have to get your developer buy-in. I mean, it's great you've built all this infrastructure, and you've got your Zookeeper and your service discovery, and things are failure resilient. I mean, you still have to go to the developers and say, hey, no hard-coded host names. Here is some example code or some libraries that we are going to support for service discovery or connecting to MySQL or connecting to HBase or Redis or what have you. We're giving you the library. We're supporting it. As long as you use this, these are the guarantees we're going to make you. If you don't use it and you go off on your own and you do stupid shit or unsupported shit, don't call us at 3 in the morning. I mean, obviously that's kind of the ideal world, and they will still call you at 3 in the morning, pages will still go off, but it's a lot easier to get your managers and their managers to buy in to that mindset when you've said, hey, do it this way, it will work. Do it that way, we told you not to. And because servers may come and go, but uptime is forever. And then finally, this is kind of a route that we chose not to take. This is platform as a service. This is still kind of an operationally Buddhist way of thinking. You're still not thinking about the physical stuff. You're actually kind of looking at it even higher level. You're just saying, hey, I don't care about infrastructure. Just give me a database. Give me a cache. Give me a CDN. I don't care about the rest. That's fine. I mean, there's no really right or wrong way to go about this. Our particular decision is to go more towards the infrastructure side. We just want servers. We will configure them the way we want them with our flavors of HBase, MySQL, Redis, what have you. We have the resources to support that, and that's what works for us. Not everyone does. I mean, if you're a 2-person shop and you don't have any database people in-house, you might use RDS. You might just, hey, give me a database. Cool. Obviously, more abstraction means more lock-in. Maybe that's okay. I mean, there's plenty of people running very successful businesses on RDS and other similar things. But just know what you're getting into before you do it. And I don't think there's really any time for questions. So the only thing I'm going to say here is I would love to take credit for operational Buddhism because I think it's the coolest phrase ever. But credit for that actually goes to Danilo Stefanovic, who is not here. But he is another one of my colleagues at Pinterest. So thank you, and enjoy the polar bear.